Morning. In this video today, we will be seeing decimal representation of rational numbers. So let's begin. For example, I have 8 upon 5 as a rational number. Now I want to represent this as a decimal representation. What do we mean exactly by decimal representation is by dividing it and writing the answer. So let us say when I divide this 8 upon 5, what I get is, now I put a decimal point here and add a 0. So 5 6 are 30. So you can see the decimal representation of 8 upon 5 is nothing but 1 upon 6. Let's take another example, 13 upon 2. So again we divide this. We put a decimal point to add a 0 here, and you can see what is happening in these two cases which we did. We are getting remainder 0 and the division is getting completed. So such type of representation is called as a terminating decimal representation. What do we mean by the word terminating? Terminating means ending. The division is getting ending. The division ends because the remainder has come as 0. So such type of representation is called as terminating decimal representation, where the division ends. You cannot divide further because we have got the remainder 0. Let's take another example and see. Let us say 10 upon 4. So again we divide 10 by 4. We put a decimal point to take a 0 so that we can continue the division. And 4 5s are 20. So again you can see we got 0 as a remainder. That means my decimal representation of 10 upon 4 is 2.5. And my division has ended. There is no further division possible. So such type of decimal representations are called terminating decimal representation. The meaning of the word terminate means to end, to finish. Our division is finished here. That is why it is called terminating. But there are some cases where this decimal or division will not end. It will keep on continuing. And such type of divisions are called non-terminating. Non-terminating means they are not ending. Non-terminating, recurring. Recurring means what? Re means to come again and again. Occur, to occur again and again. So the numbers will keep repeating itself again and again. In such type of decimal representation is called non-terminating, recurring decimal representation. So just let's see some example. Let us say 10 upon 3. So you see when I divide 10 by 3, now I add a point, again I get 10. So 10, again I do 9, again I get 1. So you can see I can keep on continuing this division and it will never end. It will keep on going, and this answer I will keep on getting 3.33333, right? The division is not getting finished. It is not terminating. That is why it is called non-terminating. And which number is repeating after the decimal point is 3. 3 is getting repeated again and again, again and again. That is why it is called recurring. Then how do you represent this? 3.333. This division will go on unending, infinite. So how we represent is the first number we write and we put a point on it. This point indicates that this division is not getting finished here. It is keeping on continuing, and the number 3 will be repeated infinite number of times. So this becomes a decimal representation of 10 upon 3. And what does this decimal indicate? That it is a non-terminating, recurring type of representation. Let's take another example. Let us say 17 upon 3. So now I am dividing 17 by 3. So 3 5s are 15. I get 2. I put a decimal point to take 0. So 3 6s are 18. Again you see I get a 2. And again you can see every time I take a 0, I keep on getting the same number. 666 will keep on repeating till infinite. This decimal representation will never end. So 17 upon 3 is nothing but 5.6666 and so on. So how do we represent it? the first number that is getting repeated, we put a point on it. So now this has become the decimal representation of 17 upon 3. And this is a non-terminating recurring decimal representation. Okay, let's take another example. 13 upon 11. So let us say 11. I'm dividing by 13. 11 ones are 11. I get 2. I put a point here. So again, 11 ones are 11. Now I got 9. Now again I put a 0. So 11 eights are 88. Again I get 2. So again I take 1. 9. So again 8. Again I get 88. Again 1. So again 8. So you can see this process will continue on and on, on and on. It will not stop. So you can see this number 181818 is keeping on repeating itself. So how do I represent this? As it will become 1.181818 and so on. So this can be written as 1 point. Now in this case, two numbers are repeating itself, 1818. So we draw a bar over 18. What does this represent? That the decimal is 1 point and this 18 is recurring endlessly, infinitely, 18181818. So that is how it is represented by a bar on it. Okay, let's take one more example. 10 upon 7. So let us say we divide 10 by 7. 7 ones are 7. So I get 3. I put a decimal point and 0. 7 fours are 28. I get 2. 7 twos are 14. Then 6. Then I get 7 eights are 56. Again I get 4. 7 fives are 35. I get 5. 7 sevens are 49. And then 1 again. So 7 ones are 7. Now you see again from here the 30 has come back again. So now I'll get on repeating the same numbers again. 7 fours are 28. So 20. So you see I've got 20 again. So 7 twos are 14. Again 60. See, 60 is repeating. So you can see these numbers will keep on repeating. So 7 upon 10. What am I getting the answer as? 1.428571. And after this again 4 has started, right? So these many numbers will keep on repeating again and again, again and again. So how do I represent 7 upon 10 will be 1.428571, and I put a bar over this because in this order the number will keep on repeating endlessly. I'll keep on getting 428571, 428571, 428571. Right? So these type of decimal representations are called non-terminating recurring decimal representations, where the division ends and no further possible. Such type of decimal representations are called terminating. But this terminating decimal representation can be converted into non-terminating. For example, this example, 10 upon 4 is 2.5. Endlessly I can put zeros in front of it because 0 at the end after a decimal has no value. So I can write this as 2.50 and I can put a decimal above that. So now this has become a non-terminating. You should always remember in the last, on the right hand side, after all the digits are over, as many zeros you put, the value of the number will not change. It will still remain 2.5 itself. So a terminating decimal representation can be converted into non-terminating by putting 0 at the end. Like for this example, I can keep on putting zeros in front of it. So this I can write it as 1.60 bar. This is 0 is only repeating. I can repeat 0. I can't repeat 6, right? Same, this can be written as 6.50 raised to the dot. That is saying 0 is repeating again and again. And always remember, adding zeros at the end, the value of the number doesn't change. Thank you.